Yes, we are live, Bhaskar. You can start.
Yeah. Okay. Good evening to everyone present here. It is my pleasure to announce that today, along with us, we have Mr. Manigandan Venkataraman, who has more than 2 decades of IT experience into consulting and product development and delivery in the domains of e-commerce, banking, telecom, healthcare, and etc. Being passionate about imparting knowledge and skills, Mr. Manigandan has delivered more than 50 corporate training programs, including Java, JEE, DB2, Websphere, and full stack development. He has mentored more than 400 freshers in the corporate induction training and project placement. At the group in analytics, which is a part of Aditya Birla Group, he is leading the engineering team for building AI platforms and solutions. Today, he is with us to talk about what is data engineering, its role, and its significance. Over to Mr. Manigandan.
Hey, good evening. Bhaskar, you able to hear me, right?
Yes, sir.
Sharing screen. Okay, I believe you are able to see it, right?
Yes, sir.
Okay, great. Okay. Hey, good evening, one and all. Thanks for joining. So it's an immense pleasure to be a part of sessions and be a part of the industry collaboration with IIT Madras and able to share my knowledge and what I have learned through these years. So today we are going to talk about data engineering. So what is it, why we need it, and how to do it. Okay, so let me actually take you through the agenda. So this is the rough agenda which we'll be following today. So we'll be talking about what is the data engineering, what is the significance and role, and typically what a data scientist versus data engineer role is, and then how to approach it, what are the concepts that you need to be aware of, what are the technology and tools that you need to be proficient in to do data engineering, what are the 10 quick summary of what we have discussed for the first 40 minutes, and then we'll move into the QA session. Okay, so if you look into data engineering, okay, what is data engineering? So let's say like you'll generally know hear about databases, data architecture, and a lot of these things. So data engineering came into prominence with the data science, AI analytics, ML. So processing data has been there for a very long time actually, even before the word analytics and data analytics and engineering, data engineering came into practice. So we have been doing this for a very long time actually. Only recently, let's say in the last decade, a lot of structuring has been done in terms of for the applications which need analytics, or when you build analytics applications, what kind of an approaches actually will actually lead into a best design of this data science applications, analytics applications, and deployment. So data engineering, if you look at it, so how to design something? Say for example, each application will have its own design. Actually, database design. Typically, you would have done normalization for a relational database models, and then you will start building data. Actually, the application connects to this design, no reads and writes into it, and all those things. So these are typical traditional applications where it is more operational. Then came the data warehouses actually. So which is primarily for the BI, business intelligence actually, these data warehouses. And then when you look at the data engineering, which is going to support the data science applications. So the data engineering is all about how you will design these systems and how to build these systems. And see, typically these systems will connect to a data source, okay, and then it will store, and then it will make present data in a format which is much easier for analysis. And this needs to happen at scale. At scale, in the sense, like say, take out any, no, like say for example, any startups today, okay, or any enterprises today. So they want to run millions of, no, they will have users, millions of users, or millions of data points, and they want to run all these things, okay, analytics workloads they want to run, okay, they don't want to run it for 3 days, 4 days. Actually, they want to run within a very small amount of time. So the systems that we design and build, that should be able to scale, You should be able to know, like run, say, let's say today there are 5,000 users. You do a promotion, and then within a week you get, let's say, 50,000 users, or the scale can be 100x also, 500,000 users, 5 lakh users, or 50 lakh users. So the scale can be 10x, 100x, 1000x also. How to run actually? So you should not be bothered about know how to configure this workload for 5,000 users, 50,000 users, or 100,000 users. So that's the scale we are talking about. Data engineering. So we need to understand how we should design these systems, build these systems, okay, which can run at scale. Collecting, storing, and analyzing is a part of any system. This is more, you will do the ETL, no, extract, transform, load, or ELT, extract, load, and transform. These are the things that we'll do. So what I thought is, instead of actually taking you through like list of steps A, B, C, D, I want to start with an use case. Okay. Okay. So I thought we'll start with this use case so that I can actually like bring some interest to the table in terms of what we are doing and why we are doing what we already understood. This is more about why we are doing it actually. Okay. So when you look at, say, let's say I wanted to start with the use case. So this use case, let's say like okay, I have a favorite band called Agam, which is into Carnatic rock actually. So you can look them on YouTube. So this is so. I want to understand as a fan, I want to understand, let's say I'm working with the Agam team to understand the sentiments actually. So there are a lot of videos. So they have actually published more than 38 music singles or albums or videos. So as a analytics user, let's say that I want to understand how people respond to these videos over a period of time. Okay. So let's say I'm actually working for Agam team and I'm going to build a dashboard. I want to build a dashboard, okay, in terms of trying to understand what are the analysis in terms of these videos. Against these videos, what are the comments that has been given by the users, whether it is a positive sentiment or a negative sentiment, what is the subscriber reaction over a period of a timeline, last, let's say, like 7 years or 8 years. Okay, I want to do an analysis of all these things. Okay, so this is the use case. So I have, what is the data source I have? I have Agam YouTube videos. That is the data source. What is the end goal? Okay, the end goal is I need to build a set of dashboards which will actually tell me how the sentiment analysis in terms of what are these videos, how the subscriber is reacting to these videos, and over a period of time, how the, say, let's say, like I have published a video. Okay, after 5 years, there's a lot of reception and sentiment. We see a lot of videos trending after 3 years, 4 years. So you want to understand which videos have done when publishing, have they done good, or after a certain time they have done good. So all these kind of analytics insights you want to derive from this. So this is the use case. Let's see how we will approach this actually. Okay, first YouTube exposes the data via YouTube APIs. Okay, so we have to write some scripts. See, these scripts can be written in Python, Java, or any language actually. Okay, any language that you're comfortable with, because APIs, they are being exposed by the YouTube so that you can consume in any language actually. Okay, so these are REST-based interfaces, so can consume it. So once you extract the data, push the data into a database. Okay, push the data into a database. And once you push the data into a database, so you need to now design the schema actually. This is what we meant by design. So you need to design the schema. So like when is the video, there will be certain attributes for each of the entities, video, subscribers, okay, and all this information. So create a database schema so that whatever information you are able to get out of the YouTube via its APIs, you can actually push into this database. And then once it is there, then you need to do a sentiment score analysis. Let's say this is more of an NLP problem. This is where your first step of data science comes in actually. So you have the data ready with you. So you have the comments. Let's say that we have the comments of all the video. Okay. So now you will pass the text to this NLP processor, natural language processing, and understand what is the sentiment out of it. So you can actually do a sentiment analysis, you can do a keyword extraction, and then you can actually mention of any other bands or any special mentions of any specific person. Like say the bass guitar was nice, or a specific instrument or something has been mentioned in the comment, or some person has been mentioned in the comment. We can identify all these things. Okay, now all these things which comes out is more of a insight that you generate actually. And again, what you will do, you will get all this information and store it back to the database. Okay, because whatever results you got, so all this information that you have is the input, and then after actually processing through this one machine learning model, in this case is an NLP, you get the data and push it actually, and then you store the insights. This is what you're generated out of it. So and then you can run other machine learning models also. Let's say like you want to understand like the clustering, like what are the who are the users who have actually done maximum positive scores or something of that. You can run a lot of other models also over here, and then you again push it back to the this one database. Okay, and then you can actually now pass this information to the visualization. So this was our source. Again, YouTube videos were the source, and then this was the final output which we done. So if you have looked at, so this is the entire data flow diagram and the process flow diagram at a very high level. Doesn't have any technical details, but this is how you would actually build a map actually in terms of how to do it actually. So then you can actually break down. This is the ETL layer that you have to break down and do it. Okay, and then this is like, say you have to you can build your NLP models or some other models. You can consume it, expose via TensorFlow, consume it via Python, or any other like, let's say you can host this on the cloud and you can do it also. Once the data is back, you can use a Power BI or a Tableau or even Metabase or even custom React based dashboards to visualize this also. So there is a lot of like tools and technologies can vary, but this is by and large in terms of the concept of what it is. So if you look at it, only this area, like the NLP and the other models processing, okay, and this is the visualization. So leave out the dark red and the blue part. So whatever you are seeing as a green, right? Those are the data engineering or engineer related work someone has to perform actually. Okay, if you look at it by and large in terms of sequencing, how we are doing it is, so you are taking a fetching a data from the source, okay, and then cleaning and preparing the data, load the data into an application schema, and again, so it's there could be like let's say you have some third party data also. Okay, let's say you have people who are associated with the band and other things, so who are playing, the musicians, all data you can actually extract from other source. You can push that into the DB also. So you can enrich the data which you have already had, and then you can generate the insights from the model. You can generate the insights from the model, and that information has to be visualized. So again, as I told you, each for achieving these of the things, the choice of tools and the technology can be anything actually. And then what happens in typical other cases? So this is like, say for example, this information. Let's say you have actually identified the list of like subscribers who has commented like positively, and say let's say there are few users who have done positively on some video, someone has done negatively on some video, so there is a balance. Okay, you want to now cluster these individuals, and then you want to, let's say that Agam team wants to meet them and to do a workshop. Say let's say like people who has been both positive and negative, mixed reviews, who has done critical reviews, they wanted to run a campaign and invite them for a workshop, let's say that. So they will have a campaign manager, right? They will have a campaign manager surveys where then they can send the bulk emails to them or a personalized emails to them, and then get them back into the this one into some activity. So for that, not visualizing the data, you need to export the data also from this thing. So again, it can actually go as an this output data which you have stored, we can go as an input to the next application. So it doesn't mean that like something has to start and end over here in terms of just the visual analytics, visualization only. So it has the filtered data or the data of interest can move out to the next application also, or the next activity in the process flow as per the demands of an organization. So a MailChimp or something, which is a campaign manager. So we can export the data and push it to there so that we can actually, they can look for protractors, detractors, do an analysis, run a workshop with them to understand what kind of a music excites them, what excites them, what not excites them. Okay. So for a few areas which the analytics cannot answer you. Okay. You can observe the trends, but why the trends are happening? Maybe you have to do a thinking by yourself, or you need to collaborate with the people to find that out actually. Okay. So that is what we are doing over here. So these are broadly in terms of, now you look at why we need a data engineer, because if you look at the NLP models or other models, I would generally tell that it's like a engine's car. So car's engine. So you cannot just take the engine alone and then go around the city. You need a vehicle which has a good body, which has a good dashboard in terms of telling you what's happening, and then wheels and every other thing no built. You need a vehicle. Basically, you need a vehicle, okay, which can work in tandem with the engine. So if you look at the your NLP or analytics models, machine learning models or data science models as an engine, you imagine the rest of the car is what a data engineering, application engineering, visualization combined together will give you actually. Okay, so you both has to do complements. No, it should be complementary in nature. So just alone a good car without an engine cannot do anything. And just an engine without a good car body, okay, which fails a crash test, let's say, without the safety features and cannot do anything. So it needs to complement each other so that the real purpose, the use case is getting satisfied actually over here. So what is data engineering doing? So if you are thinking about, okay, what a data engineer and data scientist does, so there are a lot of good articles on the internet which gives you this distinction. Okay, so data scientist thinks only in terms of how to analyze the data, okay, in the prescribed way. Okay, you can take a statistical model or a deep learning model, analyze the data, bring out the insights out of the given data through an analytical process or a model. But a data engineer doesn't like he doesn't think in terms of ML modeling and other things. He has to create the data, okay, in such a way that he has to handle the data in such a way that it is easy for the data scientist to consume, okay, and the insights that comes out of it has to be stored back also, so that it's much easier for visualization. So if you look at a data engineer, actually he collects the raw data, so that's why he runs the ETL, okay, to get the raw data, and then he prepares the data in such a format so that it is easier for the data scientist to consume it, and then once the insights come back from the ML models, store it, make it easier for the visualization, and then expose the data if required, expose the data, okay, to other systems via some REST or API or SOAP or web services, whatever is there, okay, or create an extract job, push the data to the next system, okay, in the whatever kind of an integration exists there within that ecosystem. Okay, so data engineer, he looks at how we can actually store the data in a secure way and also the scalable way. So data architecture is what he is looking at. Okay, he is not bothered about, he should not be bothered about what kind of an algorithm is running on top of it. Okay, so sometimes what happens, a data scientist may actually do some sort of a data engineering also, but it's more in a prototype stage. He doesn't do it in a production stage. In production, when any project is ready to move into production, there will be clearly defined roles in terms of multiple people with defined roles who has to do it. Okay, so but in a prototype stage, a data scientist will also perform some data cleaning, and then like making it ready for the consumption of the ML or analytics layer. Okay, and how? So say, let's say, so again, within this given time, we'll not be able to crack everything about data engineering. But what we can do in the next 10 minutes to 15 minutes is how we should develop, how you can develop yourself into data engineering. So a data engineer. So why data engineer? No, you because like you would have heard this term, like first programmer, then a full stack programmer. Full stack programmer is one who knows the front end, back end, and the database also. He should be able to trace the flow of data from any UI or any system, from the source system to the complete end system. So one who can actually go into all the stacks and one who can understand and appreciate all the stack is called as a full stack developer. Similarly, a data a data scientist, today the market demands something like he has to understand the journey of a data. He needs to understand data architecture, and he needs to understand how the data needs to be stored and retrieved, all those things. So there is a definite some overlap, like the data scientist has to understand a little bit of a data engineering at least to start with, and like senior data scientists will start appreciating the fact that they have to actually work with the data a lot, so they have to do it. So it is essential. So data engineering is a prerequisite for any data science projects or data initiatives. So people talk about data lake, people talk about data ocean, data swamp. You will hear a lot of these things, but for all these things to exist, for any analytics projects to exist, to any data lake to exist, so we need the data engineer. So he becomes the first member of any team who talks about data actually. So people can talk about data analytics, but without data engineer, you are not going nowhere. It's like planning for a trip without a seasoned driver. Okay, you will not go anywhere. So this 10 minutes, what we can think about is like what are the, how we can actually groom yourself into a data engineer. What are the things that you need to know? So first you need to understand, you should be good at one programming language minimum. Okay, minimum I'm saying. So you need to be an expert in that. Say let's say Python. Okay, a lot of now a lot of data science activities and projects and initiatives are run in Python. So in order to have a common language in the ecosystem of data science, so Python is a must. And then Scala. Scala is the JVM language. So Scala by default can handle huge amount of data, and it is huge amount, not just the huge amount of data, but it can take advantage of the hardware actually. So you hear multiple core powerful hardwares. So Scala can handle those kinds of hardware. So Python is by and large running something parallelly on a Python, or some Python is a little difficult over there. Actually, you need to do something. No, you need to put in special efforts to do something parallel in Python to take advantage of the underlying hardware. But in Scala, it comes naturally. Okay, Scala. So your most of the big data technologies are built on top of Scala. So Python, PySpark is there actually. Okay, so you need to be very good at Python and understand how you can actually, and also you need to understand how you can write code which can take advantage of the hardware. Okay, underlying hardware. So that's the first part. And then you need to understand very strong appreciation, understanding of which kind of data can sit in a RDBMS. It's a relational database, Postgres, MySQL, okay, SQL Server, IBM DB2, all these are relational databases. Okay, and then NoSQL like MongoDB, those kind. And then there are actually time series data. Let's say that you're getting a GPS ping from a vehicle, and you have 1,000 such vehicles, and then all the information is coming. Let's say a ping every 1 minute or 10 seconds. This becomes basically a time series data. You should know like which database or which database structure to pick up for which kind of data. Okay, so if you have that understanding, okay, relational database, you need to talk the language of a foreign key, primary key, okay, how to build indexes and all those things. For NoSQL, you need to understand it's a document database, okay, how to handle it, because it's not the same way that you like handle the RDBMS. And then time series data, okay, how to look at it, what is the again the best practices for all three different database products are very different. So you need to understand how to do it. So you have to have a lot of hands-on in terms of how to do these things. Okay. And then moving on, the third pillar is going to be your scripting and automation. So you should be able to write. See, most of the servers are Linux-based servers. Okay, so you should know how to write and run a shell script, because you will be running a lot of activities. You will have over a period of time, you will develop, let's say, ETL. You have to connect to a system, get that information, and then the next part could be, let's say, you would have done manually. So do some cleaning with Python and then push it to a next schema or a table, and then invoke the let's say statistical models, and then get the insights. So that could be like 3-4 blocks of code that you have. You can easily trigger them next no, next to next. You can actually change them via the shell script. And again, if you want to run it on a scheduling, let's say a cron scheduler could be used. So Linux, Unix gives you the cron by default. You can say schedule it every 1 hour or every Monday or every third day of the week. So all these kinds of scheduling is available with cron. That's a OS level scheduler that's available, or you can do it with something like an Airflow, Apache Airflow, through which you can schedule all those things. So you should be good at scripting. Also, you should know what to automate, when to automate. And then the fourth pillar is looking at what kind of a data you get, whether it can be a batch data or a streaming data. Batch data, let's say like you are getting a dump of a transaction. Let's say the GPS data is coming once in a day at midnight or something from the GPS vendor, then it's a batch data. But if all 1,000 trucks car data is coming every 10 seconds or something, it's coming to you live, then it is a streaming data actually. Like say your Ola, Uber, and all those things are streaming data systems. Okay. So what's happening? What's happening? And again, any banking transaction, you'd have seen that UPI transactions are instantaneous. Okay, I do a phone pay or a Google Pay, it immediately, UPI transactions are immediately done. But credit card transactions, let's say you have done the payment today, credit card payment today, but it reflects in your account only the next day. It is not instantaneous, it is only the next day. So those kinds of a remittance, those things are batched on a day wise actually at the end of the day. So those are batch data. So when you deal with data, you need to understand what is a hot streaming data is called hot, and what is cold, which is the batch data. So so you will have different approaches and techniques to handle this. Okay. And then moving on. Okay, all the infrastructure that you need to set up, actually, mostly, you will say like you will set up most of these things in your laptop or on the local servers or the on-prem servers to do all these things. But most of the companies are actually thinking cloud first and data first. So they will go to the cloud, to AWS, Azure, or Oracle, OCI also, Oracle Cloud Infrastructure also. So why? Because cloud provides you the scale. Let's say like I want to run some analytics which requires a huge amount of infrastructure, but in order to get the server physically in my organization, so I might need to spend at least 2 to 3 months, or to follow all the process and then get it. But in the cloud, you can actually get this level of compute within minutes or within seconds also. You can spin a new cluster within minutes or seconds, and then you can start working it. Once you are done, you can close it. It's more like like a buy versus rent model. Cloud is also pay as you go model. So you can scale at will. And once you are done with the whatever you are doing, you can actually easily stop using it, and then you pay only for the time you have actually consumed that resource. So cloud enables you to scale. Also, what cloud does is a lot of these service providers, AWS has come up with their own data pipeline, Azure has come up with their own data factory and data pipelines, so that all those things that we have talking about, right, plugging into a data source, taking the information and automating the jobs, and all these things are available as a service, which means you just need to set up, spin some, no, you can consume it as a service. You don't need to install the softwares and other things on top of their VMs and other things. So cloud, you can also do that actually. You can do that, but if let's say that you are constrained for resources or the skill set, So you can go for a managed service directly, and then you can do it. So clouds provides you with all these options of how to do it. You think about it, no, you have a kitchen, you can get the vegetables and cook. If you don't want, you can order directly from a Zomato or Swiggy and you can eat it. So that kind of an democratization of a service is available today. So similarly, you can actually buy the server, do it, do install all the software and do it by yourself, or just set up the infra on the cloud and do it by yourself. Or you don't want to take up the responsibility, you just need to consume it as a service. You can immediately use the AWS and Azure pipelines directly and start doing it. You can just get up and running as soon as possible. And then, so all these things, am I good enough? So all these first 5 things that we are talking about, is it good enough? No, because what happens is this is an evolving field where new things are coming up every other year, new technologies are coming up every other year. So you need to be always on the continuous learning path where you can actually start upskilling yourself. Let's say that this entire thing you want to Dockerize and run as a container, and then you have more containers to manage. You can go for a Kubernetes orchestrator and then run all these things in a container environment. Let's say that you have starting now working with a data science team and you want to process data at scale. So Databricks is one such offering where you can actually plug in and start using it directly. So you need to keep very aware of what are the trends in the industry, what's happening, and how you could like upskill them. There are a lot of user groups which happens across the industry, and the dedicated blogs, influencers who talk about what's happening. A lot of conferences happen about data engineering. So you need to keep your eyes and ears open and then see plugged into the ecosystem to understand what's happening. Okay, to understand what's happening, and then it again becomes a feed. It feeds into a cycle. Actually, this feeds into a feedback cycle. Let's say these are the broad level concepts. First 5 pillars are actually which are going to enable you to do that. There could be some few new concepts, new tools, new technologies evolving and going back into this. So this is going to be more of a cycle. So this I have given in a format where it is going to be sequential, but you can start from anywhere and go anywhere also. Only thing is you should be able to basically do, you should know how to code, and what are the data sources you need to handle, and then what are the target systems in which you have to write. Okay, and you have to start doing it multiple times. Let me go back to this slide. Okay, so here let's say that you have done this code for one video. Okay, but I said there are 40 other videos actually. So which means it has to be run repetitively. Okay, so what I have done for one video, I have perfected some combination or a workflow that I have to keep repeating it. And again, because the YouTube videos are being watched by people, so for again and again, so some videos today they will have like new 100 comments. Tomorrow there'll be 200. So I need to run this job, let's say on a monthly basis or a weekly basis, again and again. So which means the same set of data is going to come in. I need to identify which is the new data, which is the old data, and then I need to bring in. So repetitively, when you run it, either for multiple videos or for the same videos, there are new challenges that are going to come in actually, and you need to do it. So we need to think about scale. We need to think about multiple times repeating the same pipelines, running the pipelines on different days for a different set of information that is going to come in new. Okay, so I think we are okay. Okay, we are good. So we have another 4 minutes for the takeaways. So the data engineering is all about data. So you need to understand the data architecture. Okay, data architecture will tell you what is the entities that is participating here. Okay, you need to understand the frequency of update, like I said, the subscribers, what is the new data, old data, how to update it, whether you need to truncate and load, or you need to just update it, how to actually identify whether it's a duplicate or not. Okay, a lot of domain related rules also will come in. So you need to understand all this information also. So that's everything is about data. So you need to understand the data. preparing you need to work with multiple other business teams as well as data science to create a data dictionary. Okay, you need to understand, even though people say that exploratory data analysis, EDA, is for the data scientist, I strongly believe that every data engineer should understand the data. So you should understand, you should do an EDA to understand what is the frequency, whether so the data which comes in a specific column is unique or can be duplicate or null values are allowed, what is the quality of the data, how to create a data quality report and share it back with the stakeholders. So data architecture is everything. You should be able to understand each and every data that comes into your system. Okay, and primarily we are not competing with the data scientist and the teams. So any data engineering team, it is going to augment, enhance the capabilities of the data scientists and teams, and we are preparing the data actually for them to be consumed. So don't data engineering teams are not competitive teams actually. Okay, it's a striker and non-striker work, like playing in a match. Okay, so you are not competing. Okay, you are complementary to each other. And whenever you are writing a code, no, you should write reusable code, small code. Don't write anywhere, no, 1,000 lines of code, 3,000 lines of code, because the Python allows you. Okay, that should not be the approach. Build it as a very small functions, well-defined functions. What it do? Create a unit test so that you know that this function is doing only one thing. Think about the best practices. Okay, and use Pylint and other things to actually increase the readability of the code. You should think about templatizing something. So there are few instances where I have actually in one of the earlier projects, whether it's be Java or PHP, where you have built some code, you can use it for next 4 or 5 years in another 5-10 projects. So think about templatizing. You need to think only once. You do it, give it 100%, and try to do it in a way that it is being used in multiple places actually. And then think about scale. So you might be actually, like say for example, uh, uh, let's say that you are approaching say 1,000 rows. Okay, because they could be business could have given a sample data, so it is having 1,000 rows. But if you restrict yourselves with thought process of only 1,000 rows, so at production it will come as 1 million, 10 million, or 100 million rows. So always you think, okay, if this code or design, whatever I have done, whether it will be good for 10x, 100x, or 1,000x. Okay, think about it. Always profile your code and then understand how your code will perform when there is more load is coming actually into the system. You need to be aware of it. And then again, horses for courses. What should be the right approach and what should be the right tooling? There is no right answer. So you should actually work with your rules and what is the tech stack being adopted in other teams within your organization. So you need to think about it and see skill set availability. All will dictate the tool approach. Again, like say there is a hot data, there is a cold data. So the demands of the application, the non-functional requirements of the application will tell you what kind of a data it is coming in and how fast you should process it and how you should store it and expose that data actually. So think of it, and then it's all about experimenting. So you should try multiple approaches parallelly. Okay, if you're not sure which approach will work, and the mantra is fail fast. So it should not fail in production. Let's say after 4 months I'm going to production, or after 4 weeks I'm going to production. Whatever data, whatever the kind of approach we take, or the kind of code we write, it should not fail after 4 months or 4 weeks. If it's gonna fail, it has to fail within the same day or 4 hours, so that I know that this approach will fail, and document it actually. Okay, so that this learning can be shared with other teams, and also obsess on performance and scale. So whenever you write, you think about whether this code will perform good in the production, this code will scale into production, this approach will scale into the production, or this approach is a performance. So wherever you have a lot of IO, okay, input output, whenever you have a lot of network calls, these things are actually going to slow your entire system down. Say let's say I need to save, I'm processing like 1 million rows in the memory. Okay, and I'm going to save it. Saving it one by one row at a time, it is going to be creating a lot of issues for you. Saving it as a batch of 10,000 or 1 lakh or whatever the system allows, actually, your ORM or whatever be the bridging the driver allows. So you should actually look for. That's why I said you need to look for the best practices actually. So how to handle it. So you while in the prototype you might be writing a code which is actually 1,000 lines. So you can actually keep it configurable. So look, always think, okay, whether this code or approach will work good in a production environment, whether it will work when there are 10x, 100x or 1000x data is coming in. Okay, so I am ready for the Q&A. Let me check the queries, what has come in.
Sir, I'll narrate them to you.
So you have pinged me the questions?
No, I'll narrate it. I'll narrate them to you.
Okay, you will narrate me. Okay, great.
Yeah, sure. So thank you for a wonderful session, sir. It's been truly insightful to understand how important the role of a data engineer is in a time of data science and how a data scientist and a data engineer can work hand in hand to bring the best outcomes. So I have a couple of queries myself, sir.
Okay.
One of them is it okay for the company to expect one person to do, especially a data scientist, to do the role to have the skills that a data engineer is expected to have?
Okay. Can you repeat it again?
Actually, I was asking if is it okay for the company to expect a potential data scientist to have the skills that a data engineer is also expected to have?
See, typically I'll tell you how the entire industry works is typically you start on a multiple prototypes actually. Okay, prototypes or POC to understand whether something works. So what happens most of the times the data scientist might pick up the data from a data lake or from a business team, okay, who gives an extract from a SAP or or some other source systems. So data scientist should understand at least few techniques of the data engineering, because say like I get a raw dump data, so I should be able to do some analysis on the data, clean the data in some in say like say I got a let's say like I'm a financial organization. I want the this one like data scientist to predict, okay, which of my this one no like loan accounts are getting going to closed actually. So that I can actually reach out to them to understand what is the issue, or I can offer them a top up loan or something. Okay, so most of these activities are done for a specific business interest. Okay, so when I like say I expose a database or something or a data dump to him, I might have 150 columns actually, but data scientists will typically look into it and say like only 40 columns are relevant to me. So now he needs to traverse this data, navigate this data with ease, and understand what is it, and do it. So definitely, a data scientist in today's world has to understand and should be able to work as a data engineer, but not for large scale sets. So like this is the typical POC at a prototype stage. You cannot ask the organization, I need one data engineer to do this. Okay, because there's no work for a one data engineer over here. Typically, these kinds of what we also encourage is ask them to work with the data engineer. So we ask the data engineer not to spoon feed him, but give some specific links or explain the approach rather than giving the fish directly. Teach them how to fish, and then they can start picking up. Because like say like to give an idea also like out of 100 projects, data science projects, only 10 okay or less than 10 go to production, which means a data scientist typically works on at least 10 to 15 projects and only one goes into production. So only one he can expect a data engineer, full-time data engineer to work with him. In the other areas, he has to start working, picking up these data engineering skills so that he can be much more effective. He can no, the dependency is eliminated.
Okay,
But
so once
production systems, you will have a dedicated engineer. infosec guy, security guy, product engineer, cloud engineer. So there'll be like 5-6 teams. But to two small prototypes, you cannot expect a data engineer to be provided by the organization.
Yeah. And one other query that I had was, what is your opinion that some of the tasks that are performed by data engineers are going to get automated in the coming future, be it software engineering techniques or ML techniques?
Okay, see, whichever is repetitive, okay,
That's
whichever jobs are actually repetitive will be subjected to automation. Okay, you can say, let's say, to start with, when we are doing the, like building the blocks for any new application, so you will actually start getting the data. You will do a lot of scripts. Once you have cracked it, right, you will not run it manually. You put it on a scheduler. Okay, by that, it's a kind of automation, right? And again, you'll see a lot of citizen data scientists or a lot of these people doing low code, no code platforms, dragging and dropping, doing all these things. So both approaches work actually. Okay, both approaches are here to stay. You cannot eliminate completely a data. See, the thinking part cannot be outsourced.
yeah.
The thinking part has to be done by the humans. Anything, outside this boundary of thinking and strategy or building an approach can be outsourced, which is because that is definite actually. Okay, that can be
And like
automated,
you said,
subject to automation. Yeah.
and like you said, once we templatize the code we use for different projects,
Yes.
that's also a part of automation.
Exactly. See, those people, see, again, what happens is you are also not interested in doing the same thing, no, after 5 years, 10 years.
Yeah.
Because you hit the saturation point within 2-3 months also. If you're doing the same kind of a work, you also get bored with that work, and then you lose interest, and then your productivity goes down. So, in the best interest of you, you should start automating. And you should move to the next level in terms of taking up, no, you can actually move, abstract yourself, and then attack the higher order problem statements.
Yes. That's it for the queries, sir. Thank you.
Okay, great. Any questions from others?
I'm just checking the YouTube link, sir. I have a question from a person regarding database architecture, sir.
Okay.
He is asking if the disk storage is part of a storage manager.
Storage part of?
Is the disk storage part of storage manager? The question is about data architecture, database architecture. That's all.
Okay. See, what happens is most on the cloud, you don't need to worry about the storage. Especially when you go for any managed services, you need to understand how much of a few things like S3 or something. This one, which is an object storage. So you have an unlimited storage. But let's say like you have gone for a Postgres or some kind of a storage. Typically, you mention what is the storage space. So that I think maybe you need to attach some extra volumes to storage and all this. You can expand it. The only thing is you will not run out of space. You can expand it. It can be automated, or it can be some kind of a small intervention is required. So that can be done. But typically, your DBAs or any people who are actually handling the infrastructure will look at that this one. So it might not be your job job JD, of your job description, but typically having an eye is actually good actually. So you should understand what kind of a service you are doing, whether there is a upper limit or not. Set the notification in such a way that once it is hitting 85% or 90%, you get a alarm or something which actually comes and lands in the mailbox.
Yeah, one person was asking, can a person with 5 years experience in testing go into data engineering? Why should company give him a chance?
Okay. See what happens. See, if you are able to think and code, nothing stops you. Actually. So that's why I told about a full stack developer, right? So people who are able to understand the data, okay, your UI, database, and backend. We call them as a full stack developer. Okay, I have seen in my personal journey, I have seen a lot of people moving from, let's say, a support to a cloud role, cloud architecture role. And I have seen people with a QA background moving into automation and then moving into data visualization as well as data analytics also. So if you have the right kind of an interest, okay, and there's a good amount of opportunities. So if you let's say, but you have to be prepared. No, you have to put in a investment in terms of time and effort from your end.
Yes.
Talk, no, like learn about this. I would say that QA guy will have a good mental faculty in terms of understanding where systems will fail, okay, and how to actually look at multiple scenarios and other things. You can actually go, either go into a data engineer or a cloud engineer also. Okay, it depends on how fast you can pick it up and your pace. Okay, your, and then picking up a right mentor, actually picking up a right mentor can enable you move from one role to another, because I think the others tools, technologies and other things can be actually are standardized mostly in your organization.
Yeah.
And approach and other things you need to actually pick it up on the job. So I think 5 years of a QA guy will be definitely able to understand and appreciate what data is and how to actually start moving towards it. I think if you can follow the video I've given, like what are the, you have to start with Python, Scala or something.
Yeah.
QA guy will already know Selenium, which means he has an upper edge in terms of Java. So you know the flow, you understand data in terms of boundaries, exceptions, and errors. You understand it much better than other people. So you can actually start with the data quality, how to address a data quality issue, and all those things. So definitely there is an edge in terms of understanding our data, understanding and activities, scenarios, and all those things. Definitely, QA person can do a good job as a normal programmer also.
I think that's it for the queries in YouTube.
Okay, so I think I'm looking into the this one forms, Google Forms.
Yeah.
We got I think 2 questions over here. Okay, one is from Manish. As a second year data science student, what and from where should we do projects to work as a data science fresher after the degree? Okay, see, you don't know, like you can obviously download the existing data science code from any GitHub repository, and you can set up the environment and run it. That will be the first level in terms of existing projects, whatever like from your friend or someone has done on the internet and published it, that you can download and do it and then practice it. That's first part. Second part is do something which excites you, like I told you, right? The Agam, this one YouTube video, take the data from YouTube, whatever is whichever band you like or whichever musician you like or whatever maybe the channel you are following or something. Think about that data, getting it, and then do something on your own. When you do something on your own without others' help, then you will understand where are the challenges, why you are getting stuck, and all those things. And that will be giving you start always doing an end-to-end use case, because that will tell you about others roles also, because now you are saying that you are preparing for a data scientist. Okay, look around what kind of a data you are having. Let's say the heat wave is going on India. Okay, take some weather data, start looking into it, whether this heat wave could have been predicted 5 years back. Okay, or there is a lot of weather anomalies that are happening actually, like there is a lot of forest fires in California, a lot of forest fires in Australia. So you can see whether the weather data gives any indication about it, or what are the factors which is giving an indication. So like say there are a lot of variables which are actually linked to each other, which we might not have a current this one understanding. So start looking into it, look around you, what is the data that you look into it, because today with the TV and internet and all those things coming into your room, so you can think about what are the possible data sources, and always don't think that you should have 1 million rows to do some data activity. Okay. Think any small amount of data is also good data, but you should have a clean data. You should have clean data. So you will get some data with noise or with a lot of this one. Okay, you need to clear. Okay, you need to clear the data, clean the data, and then you need to consume the data, build something, and then you can do it. Okay, so you think about what excites you. Say, for example, you can prepare something very simple like if I have these ingredients. Okay, what are the dishes I can prepare? Do like a lot of pull data from a lot of these cooking sites. Okay, understand how you can actually like merge some algorithm with raw materials and ingredients. Think about it. What excites you, you can do it actually. You just need to try to automate it. Try to think something about this one. Shivam also has similar kind of a question. So I think the previous answer
Yes.
actually provide the same thing. So look around you. What is the kind of project will excite you? What is the use cases wherever you are actually? Let's say like you are playing badminton regularly, okay, or any sport regularly, and in a facility. So you want to take that data and tell them actually in weekdays or weekends when it is busy, okay, or what kind of a promotion actually can increase the occupancy. Look around for data, no, look around for collaborations actually.
Yeah.
Say if you know a person who is running some business, he look at his data actually. Then that will tell you. So all this and they will have real pain points. So most of the people know, like say they'll have real pain points and see that pain points can be solved by the data actually. The data internal or external in few cases actually. Then you see how you can predict something or classify something or how you can actually ease a business. Think from a business stakeholder view how you will run it actually. This is apart from the ideas which are there out there in the internet actually.
Yeah.
Bhaskar, we have any other questions?
I think that's it.
Okay. Okay, thank you. Actually, I think you will collect the feedback, right?
Yes.
Okay. Okay. Thanks for the opportunity again to collaborate with IIT Madras. Thank you guys. Okay. Thank you. Bye bye.
Thank you for coming.